Good morning, all of you. Today we are discussing about storage manager, query processing, transaction manager. What is storage management? Storage manager is a program module that provides the interface between the low-level data stored in the database and the application programs and queries submitted to the system. The storage manager is responsible to the interaction with operating system, and it is efficient storing, between how we are storing the data, retrieving the data and updating the data, and also deleting the data. The issues present in storage manager are storage access, file organization, indexing and hashing. Storage access is nothing but after storing the data within the database, the user how they are accessing the data, because the database provides the security for the data. Correct user can access the data. Otherwise, initial user can access the data, and also n number of people can access the same data. For that purpose, we are providing the security for the data. File organization. So, in n number of files, we can store the data. It access more storage in the database. This is the main disadvantage where we are storing the data within the files. And another one is indexing and hashing. Indexing is nothing but for every file we are placing with indexing. For every file we place it with index. Based on that index, we can access the student can access the files. And hashing, so duplication can be reduced here. Every file has the indexed value, so based on that indexed value we can access the file. In hashing, it reduces the duplicate values. Another one is query processing. So in query processing we have different things: parsing, translation, optimization and evaluation. The user generates the query here. After generating the query, it generates the parser tree and translator. So after generating parser tree, it translates the query into machine understandable code. It consists of relational algebra expressions. So those expressions should be forwarded to optimizer. Then it optimize the query. So that is nothing but those relational algebra expression. The expression should be optimized in the optimizer. After that, it so if the optimizer wants any data. So the optimizer wants any data. It access the data in the statics of database. From there, it access the data. The optimizer can access the data from statistics of data. And after that, done the execution plan. After executing that query, evaluation engine. In evaluation engine, if they need any data to access the data, they need any data to access, so otherwise to result that query, to access the data from database, finally the query will be executed. That is nothing but query output here. These are all nothing but the user can generate the query. Internally, it generates the parser and translator, and that query should be converted into algebraic expression. That algebraic expression is forwarded to optimizer. Within that optimizer, to execute that query, the optimizer wants some statistical data. That data should be accessed from statistic database. After accessing that data, it plans to execute that query, and execute after executing that query, send it to the evaluation engine. In evaluation process, so in evaluation process, the query want to display some relations, otherwise the tables should be accessed from data and send the query output to the user. This is nothing but query processing. So the alternative ways for evaluating a query process is equivalent expressions and different algorithms for each processor. And the cost difference between a good and a bad way of evaluating a query can be numerous. So, and estimate the cost of operations here. It depends on the critically on statistical information about relations which the data must maintain. Need to estimate statistics for intermediate results to compute cost of complex expressions. Then another concept is transaction management. So in that we discussed What if the system fails? What if no one user is concurrently updating the same data? A transaction is nothing but it is a collection of operations that performs a single logical function in a database application. Transaction management components ensures that the data remains in a consistent state despite system failures. So it's nothing but power failures in operating system, that operating system will crashes. In that case the data will be lost and also the transaction fails there. Concurrency control manager controls the interaction among the concurrent transaction to ensure the concurrency of the databases. There is the architecture for user and administrator. So it consists of Navi users, application programmers, sophisticated users, and database administrator. These are interacted with application interfaces, application programs, query tools, and administration tools. These are all are interrelated with databases. So this is the architecture for database system internals. So it is also consists of Navi users, application programs, sophisticated users, database administrator. These are interacted with application interfaces, application programs, query tools, administrative tools. This whole thing will be represented in query processor. The query processor consists application program, code, query evaluation engine, compiler and linker, DML compiler and organizer, DML queries, DDL interpreters. These are all are stored within the storage manager. The storage manager consists buffer manager, file manager, authorization and integrity manager, transaction manager. And the data should be stored within the disk storage. So the type of data, indices, data dictionary and statistical data. So the database architecture system is generally influenced by underlying computer systems on which the data is running. Either it may be centralized client server or multiprocessor or distributed one. Thank you all.